Yes, that was an old-time spark transmitter you were listening to. Let us go back and recall the early years. Radio, or wireless as it was first known, began at the turn of the century. Both amateur and commercial stations were of course crude, with very limited range. In these early days, the amateur did more listening than transmitting. The first practical receiver used a coherer. This odd device was popular until about 1906, at which time the electrolytic and crystal detectors took over. A coherer was centered around a small glass tube filled with metal filings. An incoming radio signal would make the filings stick together or cohere, which would lower the resistance and actuate a magnet. Until 1920, most all radio work was done on low frequency or long wavelength. The antennas were huge. This one is nearly a mile long. The stations used a tremendous amount of power, even for local transmissions. One of the most popular was the famous naval station NAA at Arlington, Virginia, with its powerful spark transmitter. Many an early amateur learned the code by listening to it. The distress signals from the sinking Titanic made many aware of the value of wireless. There were few amateurs prior to the Titanic disaster. However, the increasing interest made it necessary to have some form of licensing. This took place in 1912, and the first call book was issued in 1913, listing over 1,200 amateur stations. There were, however, thousands who were not licensed, as you will soon see. One of the most popular suppliers of radio equipment was Hugo Gernsback Electro Importing Company. Most early amateurs either made or assembled their own equipment. The more fortunate could buy an EI receiver. All amateur operation was around 200 meters until after the war. Now let me introduce Clarence Tuska, pioneer amateur and co-founder of the ARRL, who will tell us about the equipment used in these early days.
In 1908, when I first became interested, a cousin who had previously installed a station of his own in New York City decided that I should have one when I lived in Nyack. So he made a single slide tuning coil, an EI electrolytic detector, and a spark coil for the transmitter.
This is a typical 1912 receiver, a 3-slide tuner and crystal detector. Note the single earphone. A recent interview with Clarence Tuska told me much about the pre-licensing days.
These early days, I used no call letter. The government did not regulate amateur wireless at that time, and there was no need for a call letter. The range of the transmitter was about 1.5 miles in the town of Nyack. Later, when I moved to Hartford about 1909, I adopted the call letter SNT. SN stood for Southern New England, T for Tuska, and other people in the vicinity of Hartford used the same system.
A complete station was a relatively simple affair. The spark coil transmitter is at left and receiver at right. Clarence, would you tell us about your meeting Hiram Percy Maxim, the man with whom you share the honor of founding the ARRL?
When I was about 14 years old, I learned that Mr. Maxim was interested in getting into amateur radio. I became acquainted with him and built his first amateur radio station, which consists of a loose coupler, a variable condenser, a crystal detector. The transmitter consists of a spark coil, some condensers, and a helix.
Let us go back to those early days and actually listen to a QSO between two unlicensed amateurs, each using their initials as call letters. And here is the young amateur making a transmission. Adjusting the cat's whisker on the crystal detector, we listen to the reply. Would you tell us about later spark equipment?
In 1913 or 14, we went to a more elaborate transmitter. Maxim, with his shop and knowledge of transformer design, made it possible for us to make our own transformers and these were used with rotary gaps with glass plate capacitors or condensers as they were then known, and we were able to transmit much more reliably and over longer distances.
Now let us find out how and why Tuska and Maxim founded the league.
Maximum range at that time was from Hartford to Springfield, Massachusetts. This was a distance of about 25 miles. In my talks with Mr. Maxim, we realized that our maximum range was inadequate. However, we also believed that the man in Springfield probably could talk or transmit to a man in, let's say, Great Barrington, or another 25 or 30 miles. And that man, in turn, could transmit still further, perhaps to Albany. This led to the combined thinking that perhaps we should organize a relay to determine how far we could transmit. My own thought, being very young at the time, was that if we organized a relay for a purpose, it would be sufficient. But Maxim, with more foresight, said, oh no, when we organize a relay, we'll set something up which will be permanent and useful to all amateurs.
Maxim then took the initiative and wrote a letter to the president of the Hartford Radio Club proposing the club start a relay league. He first proposed the name American Amateur Radio League. This was soon changed to American Radio Relay League. Maxim had an elaborate station. It was from this house plans were made.
Informal organization was under the auspices of the Radio Club of Hartford, but it was soon determined that this was not the way to organize nationally, and Maxim came up with the thought that we should have a formal incorporation of a nonprofit organization devoted to amateur radio and bearing the title the American Radio Relay League. It wasn't long before I advocated that we establish a magazine. Mr. Maxim, with a little more foresight and being considerably older, saw all of the disadvantages, the continuous problem, the need to have material. However, I had an uncle who had printer's ink in his veins, and he advised me to go ahead. You will find you'll get more material than you can publish. While I didn't believe it, it turned out to be true. So we began with the first issue and called the magazine QST. This is my mother's house where we lived and where I established the office for QST and the ARRL. When the magazine first appeared, we printed a very small number and distributed many free. Those who paid for it paid 10 cents per copy, and I think that the initial offer, because we weren't sure that we'd last a year, was 3 copies for 25 cents. The distribution was made by wrapping the copy in a suitable mailing wrapper and addressing them. A little later, when we flourished a bit, we got an addressograph to address the subscribers. When we had a mailing, we incorporated invited all of the people who were willing to wrap and get their hands full of paste. After the wrapping was completed, Maxim would come with his Franklin automobile, take perhaps 2 or 3 sacks full of mail, the QSTs, to the post office, and there they were mailed as second-class matter. Yes, amateurs not only did relay work, but they also talked a great deal among themselves. However, their interests were not limited, because in 1916 we had the American border incident with Mexico, and among the amateurs there were several serving in that expedition. The situation is reflected in the August 1916 cover of QST.
The amateur was still operating between 200 and 400 meters. In fact, it wasn't uncommon for the amateur to communicate with nearby ships and shore stations which operated close to the same wavelength. The ARRL celebrated their first anniversary with the December 1916 issue. No longer was a cover a white sheet, but the familiar color cover which was to remain in effect for the next 50 years. By now, the radio amateur was using more sophisticated equipment. The advanced amateur was using a DeForce audion tube in his receiver, which he found far superior to the crystal detector. The vibrator-type spark coil seen earlier was being replaced by a high-power spark transformer and rotary gap, which worked off the 110-volt power line. Vacuum tube transmitters were not to be seen until after the war. The amateur proved his worth by relaying messages across the country. Several such events occurred just before and after the war. Let us listen to some of the more popular spark stations that participated in these events. Starting in the teens and continuing well into the 1930s, there would appear every so often in QST an article written by an unknown author calling himself the Old Man. Do you want to comment on this, Clarence?
Maxim liked very much to write, and during the course of the early QSTs, he established a series of articles written by the Old Man. He was the author, he imagined the stories, and the different titles were used. Many of them were entitled Rotten, followed by another adjective to describe the situation.
This is an interesting cover, for it shows a receiver using a cylindrical tube. It can be seen in the upper center of the receiver and is held in place by 4 wires fastened to binding posts. By now, the war clouds over Europe could be seen in our country. The May issue told about our Signal Corps and its work. It was just a matter of time. Clarence, how did the ARRL participate in the war effort?
In 1917, it was clear that many amateur radio operators could serve their country. In the leading article of the July 1917 QST, we have a title, Wanted by Uncle Sam, 2,000 amateur wireless operators. This is the start of an active campaign to get amateurs to aid the government in radio operation.
I understand you did much to further our war effort. Would you tell us what led up to your going into the service?
Time the war had actually started, and while we were working hard through editorials and covers of QST to explain the great need for radio operators, the time came when I wanted to be in the war and not telling about it. I received a commission, did some work in Washington, and then was ordered to Ellington Field, Houston, Texas, to establish a radio school. This is the workshop for the early radio students at Ellington Field. This picture is also taken at Ellington Field, showing a dugout which we built to simulate the dugouts used in the war in Europe. This is another picture of the dugout, but showing to the left a portable antenna of the V type and some of the students who had erected it. The dugout is not finished at this point. This picture shows the students looking at the portable antenna of the type in the previous picture. This includes the antenna wire, the masts which are dismantled, and the students are looking at the gear. This is another view showing the same container, 2 of the students, and in this picture they have operating the SCR-54 radio receiver.
Here is a close-up of the receiver. It used a crystal detector which can be seen at the far left. It had a very limited range, of course. I suppose one of the desirable features was the fact there was no need for a power supply of any kind.
This is the room in which code was taught at Ellington Field. There are 2 of these long benches, each one under the control of an instructor, teaching the students the telegraph code. This is a classroom at the first radio school, showing the instructor imparting a small amount of theory. Those who are not familiar with the World War I story, Ellington Field was a field to train flyers primarily, but the flyers also needed radio communication with the ground, and our function was to train the radio operators. I had been sent there to establish the radio school. The airplane in this picture is the so-called Jenny. At the lower left you'll see the antenna reel, which contained several hundred feet of wire and a lead weight fish, as it was called. At the center, above the engine, you'll see a French combined transmitter. It contained all of the elements except the key, and it was driven by a propeller to generate the power. This is another view of the same airplane showing the transmitter above the center panel of the upper plane. This shows the reel on the left side of the plane with the operator putting his hand out as if he were in the air so he could slowly break the cable which was being lowered. Otherwise, if the cable stopped with a jerk, the weight would drop off, break off, and I suspect that there are about a ton of lead weights around the field. This is the airplane showing an antenna reel located on the right. There's no significance as to the location. This shows the flame-proof key located on the right below the throttle. To the left, or about on the center, on the shelf, is a storage battery, which is used to power the SCR-67 spark transmitter. In this case, to avoid the possibility of fire, the spark is located in the container and visible through a small window. This is a better view of the spark transmitter SCR-67.
I would like to interrupt for a moment and show one of these airplane transmitters, which is in the AWA museum. The spark gap is at lower left, the spark coil at right with the condenser to the left of it. The only other component in the transmitter was a coil mounted on the cover. And here is a group photograph of the radio officers at Ellington Field. Seated at dead center with Clarence Tuska at his left is Lieutenant Elmo Pickerel, pioneer radio operator who worked with DeForest in 1904 and who 6 years later became the first to communicate from an airplane to ground by radio. Tuska was eventually transferred to the firing center at Camp McClellan. And now, what is this building at Camp McClellan? Don't I see an antenna above the roof there?
That was the mess shack, which we converted into a radio school. Above the center of the shack, you'll see the antenna, or supports for the antenna. This is a better view of the antenna on the radio shack at Ellington Field. This shows the code instruction room in the building at Camp McClellan. This is a view of the same room converted into a classroom where a small amount of theory was taught, as we couldn't spend all of the time training the operators for code. We are now showing the erection of an antenna using the portable pack at Camp McClellan. The students were arranged in two teams, and they would race to see who could get the portable station into operation first. Another view showing the portable antenna pole being erected. This is a staff picture taken at the University of Texas in Austin, showing the school, which had grown greatly about the time that I was ordered elsewhere.
And what happened when the war ended?
Armistice came during the end of my tour of duty at Camp McClellan. I was very anxious to get home. I wanted to get into the commercial activity of radio as distinguished from the amateur end. So I quickly sought my discharge papers and went to my home in Hartford, Connecticut.
For a short time on his return, he's with the ARRL, and then he left and formed his own manufacturing company. He was later an executive with the Atwater Kent Company and retired as Director of Patents for the Radio Corporation of America Laboratories. Hiram Percy Maxim remained with the League, and here he is operating his station 1AW just after the war. I'm sure all amateurs are familiar with the call W1AW. It was originally Maxim's personal call, and after his death in 1936, became the official call letters for the ARRL station. Note there was no W. The W prefix wasn't added until 1927. The ARRL can be proud to have as its founders Hiram Percy Maxim and Clarence Tuska, two great radio pioneers and equally important, two very fine gentlemen. Here is an early post-war station using tube receivers. The old rock crusher spark transmitter, seen at left, had only a year or two before it would be banned. However, old-timers still love to hear the sound of these mighty giants. By 1922, the vacuum tube transmitter had taken over, and some amateurs were even experimenting with voice transmissions. But that is another story. I hope you enjoyed our little show covering the early years. Thank you.